Alright, so this is solving 1 and 2 step equations. Notes is your first set of notes. Remember, this is all algebra review, so this stuff should feel very familiar to you. Like I said, whatever you already know, good. Whatever you don't know, catch it, and let's keep it moving. Okay, so a mathematical phrase made up of variables and constants is what's known as an algebraic expression. We call it an expression instead of an equation because it has no equal sign. That's the difference between an expression and an equation. Now, you can put two expressions together and put an equal sign in the middle, and then they become an equation. An expression is just, for example, something like that that's down here in this box. A times b squared plus c. That's an algebraic expression. Has no equal sign. Evaluating expressions. Follow the order of operations. Y'all should know this, PEMDAS. One thing I will say that kids don't understand about PEMDAS is parentheses, exponents, multiplication and division, addition and subtraction. Meaning, this is the order you go in, parentheses and exponents, but when you get to multiplication and division, those two are inverses of each other. So whichever one you see from left to right first, that's which one you do first. It's not necessarily saying do multiplication first. If I'm reading an expression left to right and I see division first and I'm on the multiplication and division step in PEMDAS, I'm going to do the division first. And then once I get to the multiplication, you read from left to right, then I'll do that. These two are grouped together. Same thing with addition and subtraction. They're grouped together as well. Whichever one you see first out of those two from left to right, that's which one you do once you get to that step in PEMDAS. So example 1 here, we need to evaluate a times b squared plus c. And it says if a is equal to 2, b is equal to 4, c is equal to 7. Should be easy one for y'all to do. All you're doing is plugging in these numbers for the variables. Rewriting this expression. So this expression should look like 2, and AB is multiplication. So put a multiplication symbol there. 2 times B, which is 4, squared plus 7. Haley, order of operations tells me I should do what first in this expression that we wrote? The exponent, right? There's no parentheses, so we can skip over that. So we need to do the exponent first. I do my stuff line by line. I know some of y'all try to do all the stuff together. That's where y'all screw yourselves up. I do one thing at a time. 2 times, and then I'm going to do my exponent. 4 squared is 16 plus 7. And then after that, based on what we have next, we should do multiplication and division from left to right. From left to right, only thing I see is multiplication. There is no division in this. So I'm going to do 2 times 16, 32, and then 32 plus 7, 39. Like I said, that should be familiar to everybody. I mean, we just daily stepping this thing right now. Moving down. Parts of an expression. So you got a long expression here. We're going to talk about the parts and break it into its parts. First part of an expression, you have variable terms. Variable terms are terms with a variable attached to them, basically. In this expression up here, Rosario, how many variable terms do we have? Say it again. 3 of them, right? Can you name them for me? A little louder. Don't be ashamed, bro. I'm doing it. 7x. Say it one more time. Good. Negative 5x. That whole thing is returned. Sign and off. And what else? Yeah, 4x, a positive 4x. these are my variable terms. 7x, negative 5x, and then positive 4x, so 4x. Constant terms are the other terms, ones that don't have our terms without variables. My constant terms in here would be 3, the 8, and negative 1. So 3, 8, negative 1. Make sure you always keep the signs in front of your term. That's what some of y'all mess up. That's what a lot of y'all messed up the other day. Y'all get not carrying a sign. And then coefficients. When you know that your coefficients are, it helps you combine like terms. Coefficient is just the number next to the variable. It's called a coefficient. So our numbers next to our variables are 7, negative 5, and 4. It says you can simplify algebraic expressions by combining like terms. This means to combine common variable terms and constant terms. It says simplify the expression below, the same expression we had before. With this expression right here, we've already grouped it. That's the thing I would suggest for y'all. Y'all that have a hard time combining like terms, you can regroup your expression. And we kind of already have up here, so we just write it out the way you see it up there. So I'm going to write it out as, let me go ahead and blue. Can't work better. 7x minus 5x plus 4x. And then plus 3 plus 8 minus 1. I'm just grouping my stuff so all my variables together, then my numbers together. So my variables is 7 minus 5. Which is 2 plus 4, leaves me with 6x. Then 3 plus 8, 11, minus 1, leaves me with positive 10. So when I group and I combine my like terms, my simplified expression would be 6x plus 10. You might be asking why it's important for you to know this. You probably already know this. You got to make sure you know it because we can show you down here how you may have to apply it in geometry this year. Sometimes, and I've even seen it on the EOC, they'll give you stuff like this and they'll ask you to write an algebraic expression representing the perimeter of a figure. So geometry application says give the perimeter of each figure that has a simplified expression. Y'all do know what perimeter is, right? Kobe, what's perimeter?
Like the outside of it?
The outside, but everybody always says, give me a better definition.
Like the edge of it?
That's the same thing. If you measure a perimeter, what are you measuring? Somebody tapping. It's Andy tapping. The main one probably need this. You sleep. You feel like you sleep. Turn your head up. What's perimeter? I want you to hear this. You're going to need notice for this shit. Anybody? Don't Google it. No, area is inside. That's the space inside. Huh? What about the border? I know y'all just saying outside border edge. Tell me something about it. No, that's the area. What you want to say? Put your hand up. Dad, you going to say what you want to say? No, perimeter is the distance around a figure. It's a measured distance around a figure. Like, it's not outside. I mean, it is outside, but what about the outside? You want to know the limit or the distance around a figure. That's the perimeter. All right. In this case, they want to know the perimeter of this triangle represented as an expression. They only gave us the expressions. They didn't give us any numbers as far as like just add 3 numbers together. So you have to add the expressions. So it'll be the perimeter will be equal to 2x plus 1 plus 3x plus x. But then it says simplify that. You cannot leave that as that. So now you need to combine like terms. On this one, we only have one number that's not a variable. So we don't have to regroup for this. You can pretty much see it without it. On this one, we have 2x plus 3x plus x. 6x, and then plus 1. This will be my perimeter of this figure as a simplified expression. Our next one. Yeah. What's your name again, man?
Easton.
Easton, that's it. Sure. Easton, what figure is this?
That is a rectangle.
What you know about rectangle?
I know that it has 4 sides.
Good.
And it's not a square.
Okay, I agree with that.
2 sides are longer than the other 2.
This is true. The only problem with this, Easton, when we give the perimeter of this rectangle, they only gave me expressions on 2 sides. What would you do?
I would combine the expressions together by perimeter because you have one of the sides already for 2, you know. The 2 on the end, you already have one equation for it, and the 2 in the middle, you already have one equation for it. So technically, couldn't you times that together? That'd be like times 2.
Exactly. This is what I want you to figure out for me. That's exactly what you do, bro. So let me show you what Easton's saying for those who can't make a connection. He's saying this top side right here is the same as the bottom side. This is actually how we do this in geometry. It's called side markings. I'm showing you these 2 sides are the same. We're going to start using the word congruent in next week. But I'm showing you these 2 sides are the same / congruent geometry term. And then also, you should know that these 2 sides are the same. You should know properties of a rectangle. You should know some of the properties of a rectangle at least. If that's the case, you can still write an expression even not knowing what the other 2 sides are because they're the same. And like Easton saying, all I would do is times 2. So this is what your expression would look like before you simplify it. It would be perimeter equals 2, and then in parentheses, I'll do the top side first, 3y minus 5, plus, remember this perimeter, so you add 2, then in parentheses, y plus 2. Back. Y'all follow how me and Easton set that up? If you don't, I can explain it again. Anybody confused? Don't let that break your brain. It's easy. All right. We need to simplify this. What do I need to do? What Easton wants to call it?
You need to, I don't remember what it's called, but you times 2 to the 3y, and then you times 2 to the 5 negative.
Jason, what's it called? Sorry, what's it called? Oh. Distribute. There we go. We're going to distribute the 2 to the 3y and the negative 5, like Easton said. We're going to also distribute that other 2 to the y and 2. And rewrite this. So P equals 2 times 3y, 6y, 2 times negative 5, which is negative 10. And then plus 2 times y, which is 2y. And then 2 times 2, which is 4. So that's my expression after I distribute. The next and last thing you need to do is combine like terms. Got like terms here and here. And then 2 constants here and here. Should have boxed one and stuff with the other, my bad. So 6y plus 2y, 8y. And then negative 10 plus 4, negative 6. So the perimeter of this figure would be represented as the expression 8y minus 6. Questions? Anybody writing? The back X, one-step, two-step equation. This is a little pretty quick. Let's step one get down to the end. Should be easy for y'all. To solve one and two-step equations, or one-step equations, excuse me, they have an equal sign. Get the variable by itself. This is called isolating. So, next word, variable. That's called isolating. Once again, all things y'all should know already. Just refresher, because you obviously need it. So 3 words, equal, variable, isolated. I mean, y'all really don't need my help on the report. Can I just trust that y'all gonna get that right?
Yeah.
I don't need my help on none of these. Do them free. Yeah. Get these free. Get these free. Right there. Yeah. 4, 5, 5, 6. Yes. Yes, sir. Number 5 was what did you move?
9, -9.
How you move it?
I added it.
That's the only one I really want to show you. Sometimes y'all mess up on this. I don't know what y'all be thinking about. I've seen kids in the past. But I think y'all think everything's supposed to move to the right for some reason. If your variable's on the right, you can't move stuff to the right. You gotta move to the left. And this, we have no choice but to move this -9 to the left by adding it. I've seen kids in the past that move this 2 and then automatically just throw the variable on the other side. That's illegal. You can't do that. It has to be this 9 on number 5. That's the only one I want to show you just because of that. The other ones y'all should not do. And then at the end, if you don't feel satisfied, you can flip it around. One-step equations, that's child's play, man. Let's do the two-step stuff. And that stuff at the bottom. Two-step equations. To solve two-step equations, undo addition and subtraction first to remove the constant sign, and then undo the multiplication and division to remove the coefficient. The coefficient, remember, that's the number that's in front of the variable. So you want to work backwards. It's kind of reverse of PEMDAS. Because in PEMDAS, you know, you do parentheses, exponents, multiplication, division, then addition and subtraction. If you solve an equation, you go to addition and subtraction first, then multiplication and division. You're undoing something, breaking an equation down. All right. On this one, obviously, subtract 8. And I know y'all teachers last year would do all the box, the variable, draw line stuff. You still comfortable doing all that? All right, you're not. If that's what you love to do that. I don't do all that. I'm not babies no more. Because I don't think. You know what it is. You know what you should be solving for. 6x. 50 minus 8. That's 42. Divide by 6. Divide by 6. X equals 7. I think we had a couple on here like that. Again, I didn't even answer these. On that baseline the other day. Number 8, same situation, moving fast. Only thing about number 8, once again, your variable's on the right. You should be moving stuff to the left. Move stuff away from the variable. 9 first. Other thing I noticed with some of y'all when y'all doing y'all work, when you get to this point, 4 equals -4k. When you divide or multiplying, you carry whatever sign you have with that coefficient. So it's -4 times k, I'm going to divide by -4. changing the sign is not you inversing it. The inverse of it is going from multiplication to division. Y'all get confused on that sometimes. Cancel. -1 equals k, or k equals -1. And then the main two I need to show you, these are the ones I'm trying to get to. And I saw a lot of y'all struggle on this the other day. Number 10 specifically. Because y'all confused on what to do. These two problems look similar, but they're not the same. Number 9, you got 3 over 5x plus 22 equals 28. You got a fraction in number 9, but it's just a fraction times x. On number 10, you got x plus 11. All of that whole expression on top being divided by 8 equals 3. A lot of y'all don't know what to do when y'all see this situation. I'm going to help y'all through it. Help you understand the difference. On number 9, first thing I want to do is move the constant, which is 22, subtracting that to the other side. So minus 22. So I'm left on this side with 3 over 5x equals 28 minus 22 is 6. You got a couple options here. If you get in this situation where you got your fraction with your variable attached equals 6. I can, as we told you out to the side, you can get rid of the fraction by multiplying by the reciprocal. Y'all should have heard this word before. See if I can spell it right there. Oh, it's over there. I got it. Yeah. Reciprocal. You can multiply by a reciprocal. The reciprocal of 3 over 5 will be what? Not everybody at once. 5 over 3. Reciprocal just means you flip the fraction. How do you shouldn't be confused about that. To get rid of a fraction, I can multiply it by its reciprocal. Reciprocal of 3 over 5 will be 5 over 3. You should know why that works, but if you don't, on top you do 5 times 3, 15. On the bottom you do 3 times 5, which is 15. 15 over 15 reduces it down to what? 1. That's you getting rid of the fraction. Multiplying it by its reciprocal. You turn that into 1. So that now becomes 1x, or x, on this side. And then you do the same thing on the other side of your fraction. Times 5 over 3. And you got a whole number times a fraction. Before you can multiply, you need to turn this whole number into a fraction. Put a 1 under it. Then it's 6 over 5. 6 times 5, excuse me. And then 1 times 3. When you multiply, you just go straight across. Top and bottom. So 30 over 3. 30 over 3 reduces down to 10 if you just divide. 30 goes in, 3 goes in 30 10 times. That's one option, doing the reciprocal route. Another option, I should call this option 2. Let me do it in red. Option 2, or method 2, would be making a proportion. Proportion. There we go. Let's zoom in on this. I'm going to start that right here. 3 over 5x equals 6. Start back to where we were right here. I can make it the proportion by doing this. Put in a 1 under the 6. And then you should have learned last year how to cross multiply. Cross multiply here, cross multiply here. Cross multiply. You can only cross multiply when you have an equal sign between two fractions. 5 times 6 will give me 30. So on this side I'm going to write 30. Put my equal sign in the middle. And then 3x times 1 3x times 1 is 3x. And then you got 3x equals 30. Divide by 3, divide by 3. X equals 10. You have two options to solve. Once you get to that point, it's really up to you. You can do the reciprocal option or you can do proportion. And you just need to recognize that's what you need to do in that situation. That's one number 10. That's the one I say everybody gets confused on. X plus 11 over 8. This whole expression is being covered by the number 8. A lot of y'all try to move the 11 first. How can you move 11 when it's being divided by 8? You can't. I hope you know that. In this case, since that whole expression at the top is being divided by 8, that 8 has to be moved first to solve it. You got to do that first. So once again, you got a couple options with this. I can do the same thing I just showed you. I can make a proportion and cross multiply if I wanted to. Do it that way to move the 8. Or I could do reciprocal, as we did over here. On this one, honestly, proportion would be easier. There's just so much junk at the top. Reciprocal on this one, you gotta understand you're not flipping this whole thing because I'm just really just trying to get rid of 8. Reciprocal is this would really be 8 over 1. I would not move all this. So that's why I think on this one, I'd rather just teach y'all the proportions because I don't want y'all to be confused. On this one, we want create proportion here. Put a 1 under that. Cross multiply. Here, here. When you cross multiply, you need to rewrite this as, so since the time is in this expression up here by 1, it's going to just turn into itself, so you don't need to do distribution or nothing like that. It'll just be x plus 11 equals, and then 8 times negative 3, which is negative 24. And then from there you just solve as you would a one-step equation. Minus 11, minus 11. Cancels. X equals negative 35. So that's a quick overview of two one-step and two-step equations for you. So you can get some practice on that today, and then tomorrow we're going to look into the multi-step